Academy. Today I am going to give a demo lecture on pointers in C language. So pointers are very widely used in C language because they are very efficient in terms of execution. That's why most of the people prefer to use pointers. And programming is also a little bit easy if and only if you are familiar with the pointers. It's a bit tricky, but if you apply a little bit of logic, then it is easy to understand. So I will give a detailed description and at the same time the foundations to understand pointers in C language. First I will talk about a variable and how the variables are stored in the computer memory and what is address and what is the value and what is pointers, how pointers are actually stored in the memory and how to understand the notion of pointers and the intuition behind the pointers. This is a simple program in C language. As you can see, it is self-explanatory and nothing great about it. It's a very simple language. Let me just explain this program. So my program started with a couple of global variables declaration. So these two are called global variables, A and B, and my main started here. And these two are called local variables, and scanf will read the value into my variable y from the standard input, and printf will display the value that has been read in variable y. Okay, so now let's see. Okay, first let me explain what is global and what is local. For the people who doesn't understand global and local, let's say if the variable is global, which means it is global to the entire program. This is just a main function. Let me define another function, f1. Let me define another function, f2. So, can I access A here? Yes, you can, because it is global. Can I access B here? Yes, you can access. Can I access X in f2? No, you cannot, because this is X is a local variable, local to the main function, so it is not visible to f2. Only globals are visible to the functions which are defined outside of the main function. Clear? Now, let's understand where these variables are actually stored in the memory, because computer is all about memory, and whatever you write in the computer, everything has to be stored somewhere. So this is the typical representation of the RAM. RAM is called random access memory. When you buy any laptop or desktop, you prefer higher RAM. You say 4 GB RAM and 3 GB RAM, something like that. Higher the RAM, then higher the performance, because all your applications will run inside your RAM. So what is RAM? RAM is typically organized like this, and RAM contains basically 4 sections: code section, data section, stack section, and heap section. What is code segment? What is code segment? There is another name called. We can also use a name segment instead of section. Code segment, data segment, stack segment, and heap segment. So my program, let me name my program as program1.c. Okay, so what happens when you compile? What are the basic steps in executing this program? First you will compile, and then you will run this program or execute this program, right? So what happens when you compile? This is my C language code. My computer doesn't understand my C language. It can understand only zeros and ones. So somebody has to translate my program into a program, a code which can be understandable by my computer. Who will do that? That will be done by your compiler. When you compile a program, it actually translates your program in high level language. In this case, it is C. High level language to low level language. So most of the times the low level language is called assembly language. So thus my C code will be translated into assembly code. When you run basically has two parts to it. One is linking and another is actual execution. So when you do link and execution, this ASM code, this assembly code will be converted into byte code. I mean to say zeros and ones. So which will be understandable by my computer. So effectively what I am trying to say is, when you compile the program, that program must come to your RAM. So this program one will be translated into low level language code. That code will come here. Okay. So your low language translated code will come to code section, code segment. Okay. Now come back to what is int A. Int is a data type which takes 4 bytes. 4 bytes of memory. That means A is a variable name and that takes 4 bytes. What does it mean by 4 bytes? 1 byte is equal to 8 bits. Isn't it? So what is a bit? Bit can be either 0 or 1 because computer understands only zeros and ones. So what is 1 byte? I can represent like this. 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7 is 8 bits. So 8 bits is equal to 1 byte. So like this, it is 4 bytes. So what is the maximum number that 8 bits can hold? If I assign all ones, then this could be the maximum number. So the value of all ones is 2 power 8, which is 128. Okay? Okay, so this is how the memory is organized inside the RAM. That means memory means it's all bytes. Bytes are bits. So what is there in the memory? It's all zeros and ones. Okay? So when I say int A is equal to 10, so this is a global variable. So in C programming, all global variables will be stored in data segment. Come to main function. These two are local variables. All local variables usually will be stored in stat segment. So my program is in the code segment, my local variables are here, my global variables are here, and this will be running in your source code. Okay, so how my global variable is stored inside the data segment? As I mentioned, so computer is all about memory. So what exactly is the memory? So in computer, memory is nothing but an address to locate. Let us say, when I say int A is equal to 10 and it's a global variable that gets stored in data, what does it mean? My RAM will look like this, and it is in terms of addresses. Let's say if address starts at 0, I can say like this. It is divided into address 0, 1, 2. Usually address will be in hex. So something like this: 01, 0x, 1ff or ffc, something like this. So, and after this 0x, 1 ff, after c, this is d. So it goes like this. Okay. So for our understanding, I'm just using integers. Okay. This is 0, 1, 2, 3, or let me use 1000. That is better, easy to understand. Okay. So this is 1000. This is 1001. This is byte. Okay. So what is the difference? This is the base address. 1000 is my base address. From here to here, the difference is 1 byte. So this is 1002, something like this. Let's say my data segment started with 2000. So 2001, and this is 2002, and this is 2003, and this is 2004. So when I say int A is equal to 10 and A takes 4 bytes, so how this actually gets stored in the data segment means A needs 4 bytes. So let's say I have started here 1 up to here 1 byte, 2 bytes, 3 bytes, 4 bytes. 1, 2, 3, 4 bytes. Right? So this entire memory, this entire address means from 2000 to 2004 is 4 bytes, and the name of this address is A. As simple as that. So my A, I have my computer program will give this particular address to a name. That name is A. Okay. So what is the value of A? It is 10. Simply, so in this entire memory, 10 will get stored. Clear? So this is the address, and this is the number. Depends on the number of bytes. Let's say if I define char x, char takes 1 byte. That means, let's say my char x is a local variable, then it comes here. And let's say my stack segment started at 3000, and this is 3001. So my char x takes only 1 byte, so char x will come here. Okay? So that's how the variable gets stored in the RAM. Okay? So now, come back to our C program. So far what we have learned, so far we have seen how the memory is organized inside the computer memory. This is RAM, it has 4 segments. My source code will run in 4 segments. Global variables come to data, local will come to stack, and the program will run in the code segment. So when it comes, when the program is executing step by step, everything will get stored in the data, stack, and heap segment, something like that. So now I have executed up to this point. Now let's come to this point, scanf. So what happens at scanf? Scanf, the meaning of scanf is it has to read the value from standard input. So when I run this program, so it will display this value. It will display the string, enter value of 5. Then your cursor will stop here. That means you need to enter a value, right? Let's say if you enter 25, then it will pick 25, and immediately it will display, because printf value of y is 25. So what exactly is happening here? It is getting the value from keyboard, but why I am using ampersand here? So far I have explained how variables are stored. Now let's understand ampersand symbol. What is the significance of ampersand symbol? What is the meaning of it? So ampersand symbol, the meaning of ampersand symbol, there is another name to it. The another name is address operator. That means if I say y is a variable. If I say y, that means value. If I say ampersand y, that means address of y. Okay? So just y means value, ampersand y means address. So as I mentioned here, so every variable will have a address and a name and a value. Right? So address, as I mentioned, if it takes 4 bytes, then this is the base address, 2000 here in this case, my base address. Name, A, value 10, something like that. Okay? So if I say ampersand means address 2000. If I say y means 10, value. Okay? So that is the significance of ampersand and y. Okay. So far we have seen the notion of variable and how variable gets stored in the computer. Now let me give a technical definition for pointer. What exactly is a pointer? So the definition of pointer is like this. So pointer is a variable which holds the address of another variable. So pointer is a variable which holds the address of another variable. What is the meaning of it? Let me just give you a simple example. Okay, let me define char x. Okay, x is equal to 2567571234. So how much is the number? It's a big number. Okay, so what is the mistake? What is the mistake in this simple 2 line source code? there is a mistake here. I define char x, fine, no problem. And I assign a big number to char x. What is the problem here? X is of type character. That means if I assign this huge number to x, it cannot hold because the maximum limit of x, because it is character, is 2 power 8. So it cannot hold this number. Similarly, addresses, as I mentioned before, addresses are in hex format. As I mentioned, f, something like this. Okay. So normal variables, I mean to say integer, character, long or double, cannot hold these huge numbers. That's why we need a special variables called pointers to specifically to hold the address of another variable. Okay, so that is the whole definition of a pointer. So pointer is a variable similar to integer, character, or something like that, but it is not a normal variable, but it holds the address of another variable. Okay. So why do we need to hold the address of another variable? Let me give a simple example. Let's say I have defined a character a of 10 and now I am trying to access a of 3. Okay? But let's say I have a pointer which is pointing to a of 3. Okay? If I access the third variable using a of 3, if I access the third variable using pointer, in these two cases, using pointer is faster than using an array. Okay, that's why in the beginning I said using pointers is efficient and it will speed up your program execution code. So accessing through pointers is faster than accessing using the subscripts. Okay, because pointers directly holds the address and it will directly get into your RAM and it will access the memory. Now let's understand variable in little bit deeper. Okay, as I mentioned, p is a variable which holds the address of another variable. I have defined x here. Okay, so this is my x. Okay, my x is integer. As I mentioned, integer take 4 bytes. So from 1000 to 1, 2, 3, 4 up to 1003. Right, this is 4 bytes. Okay, and address. What is the address of? This is the name. X is the name. What is the address of x? That is 1000. Okay, this is the base address. Okay, so up to the end address will not be stored, only base address. What is the value of x? It is 10. Now, this is the syntax to define a pointer. Okay, it must start with a data type. Whether you want integer whether you are holding the address of an integer, then you have to define integer. Let's say I want a pointer which holds the address of character, then it must be character. Okay, here I want to hold the address of another integer, so that's why I define integer here. And this is the notation. You have to use *p for defining the pointer. Okay, so now what is my pointer variable name? P. Even though pointer is a separate variable, that also must be stored in RAM. That means, let's say my memory is 2000 here and 2001, 2, 3. Okay, assume my P is stored here. Okay, so this is the address 2000P. Okay, now I assigned like this. P is equal to ampersand x. What is the meaning of it? As I mentioned before, ampersand x means address. Address will be assigned to P. The value of P now is the address of x. What is the address of x? 1000. Okay. So the address of x is assigned to the value of P. Okay. Now, how can I retrieve the value of x? Let's say if I use *p, as I mentioned before, if I use only p, the meaning of p is just a value. Okay, whereas *p and p both are same. star p means value of p. Okay, star p means value of p. What is the value of p? It is 1000. What is 1000? 1000 is pointing to another variable, that is x. What is the value of x? 10. So star p will give you 10. If I just say p, what is the value of p? This is 200, 2000, because address of p is 2000. Value of p is 10. Okay, so that means here my value in these 4 bytes is 1000, whereas my value in this 4 bytes is 10. Here it is 1000. Okay, so when I say star p means it will go to the value of p. Value of p is the address of another variable. Then it will go to the address. The address is pointing to another value, that is 10. So it will give you 10 here. Okay, so that is the simple understanding of pointers in C. I will give you another interesting thing, then I will conclude. I is equal to 10, I plus plus. What is the value? It is 11. Okay, now in this case, star p, or I would say p plus plus. P is a pointer. Let's say p value, as I mentioned, p value is 1000, right? The address of p is 1000. Because it is an integer, so it will range from 1000 to 1003. But the base address is 1000. Now what is p plus plus? I means 10 became 11. P is a pointer. P, the address will be incremented. How much? Is it 1001? No, it is not 1001, because it is 1004. Because p is integer. Integer means 4 bytes. P plus plus. Then after 4 bytes. After 4 bytes is 1004. It will become 1004.